Hi, I am Sanjay Patel. In today's lecture, we are going to discuss intersection of two spheres. So let us consider equations of two spheres, any two spheres in the Cartesian form like this. I will call the two spheres as S1 and S2. So let me take the first sphere S1, whose equation is x square plus y square plus z square plus 2u1x plus 2v1y plus 2w1z plus d1 equal to 0. And another sphere S2 is given by x square plus y square plus z square plus 2u2x plus 2v2y plus 2w2z plus d2 equal to 0. These are the two spheres, be two distinct spheres in R3. Okay, I am also assuming that centers of the two spheres, rather the radius, are different and the centers are also distinct points. Okay, you know what is the center and radius of each of the sphere, how to write down the center and radius. So here the center of the two spheres, centers of the two spheres are of S1 and S2 are respectively, we can take the center of the first sphere as C1, and this point, you know how it is obtained, just by dividing the coefficients of this x, y, z by 2 and giving the opposite sign. So it will be minus u1, minus v1 and minus w1. And for center of the second sphere is similarly minus u2, minus v2 and minus w2. Okay. Also the radius and the radii of the two spheres are, say, R1, let me use the same color, S1, I am using the radius of the first sphere R1 as, you know, the formula of this R1 is u1 square plus v1 square plus w1 square minus d1. And for the second sphere, the radius is R2, which is given by u2 square plus v2 square plus w2 square minus d2. Okay. So just remember that we are taking here R1 is not equal to R2. We are assuming that R1 is not equal to R2. So the two spheres are not identical. Okay. What we are going to discuss is if you are given two spheres equations, then how to determine what is the relation between these, whether they are intersecting or not intersecting, or what is the situation between this. Remember that spheres are nothing but set of points, or you can say they are surfaces. So if we have two spheres, what are the possibilities? Just think about it. Suppose I have two spheres, one is like this, another is like this. Okay, then if the two spheres are in this form, say C1, C2 are the centers, and this is the radius of the two spheres, say R1 and R2, then you can see that two spheres are not say intersecting at all. Okay, so you can say the intersection of these two spheres is empty, or they are disjoint spheres. So we want to discuss all such possibilities. Can you think how many possibilities are there? We'll discuss the different rules for determining the intersection set of the two spheres, or the condition for the intersection of the two spheres. So first step is, as I mentioned, given the equations of the two spheres, find out the centers C1, C2 from these equations like this, and then find the radii also using this formula, which we already derived in our earlier lectures. And then in addition to this, you find this distance. Find the distance between the two centers. Find the distance between the two centers C1 and C2. That is, C1, C2 is given by, as you know the distance formula, you can have this way: U1 minus U2 square plus V1 minus V2 square plus W1 minus W2 square. Because the coordinates of C1, C2 we have written earlier, they are minus U1 minus V1 minus W1, and C2 is this. So taking this x2 minus x1 square plus y1 minus y2 minus y1 square plus z2 minus z1 square, like that. Okay. So first step is obtain C1, C2, then find R1, R2, and then find the distance. Okay. Now according to the relation between C1, C2 in this radii, we can have different situations between the two spheres. So let us see one by one the different cases. Okay. So first case, I am taking this way. Say first case, let us call it A. If C1, C2 is strictly greater than R1 plus R2, then that is the distance between the two centers of the spheres S1 and S2 is greater than the sum of their radii, then we have the intersection S1 intersection S2 is equal to phi. That is the two spheres do not intersect each other. They do not intersect each other. So what will be the, you can say, the situation? You can draw the figure like this. So I am taking one sphere. So this way. This is one sphere. Let me put it here. And another sphere I am taking as this way. Two spheres maybe of different size. Okay. And suppose the center of this sphere is somewhere here. Sorry. Okay. So center of the first sphere is here, say C1, and the center of the second sphere is here, say it is C2. Let me call the two spheres as S1 and S2. And this is the radius of the first sphere, that is R1, and the radius of the second sphere is this, that is R2. And it is clear the distance between these two centers is obviously greater than R1 plus R2. So in this case, we have S1 intersection S2 is equal to 5. So we have S1 intersection S2 is equal to null set. So this is the first case. Okay. So after finding C1, C2 and radii, just check this condition. The distance between the centers is greater than the sum of the two radius R1 and R2 or not. Now case 2. So case 2 is this. If C1, C2, the distance between the two centers of the spheres is exactly equal to R1 plus R2, then in this case, the two spheres you can imagine now are touching each other externally. Okay, we can also say they are tangent to each other externally at one point. That means the intersection of the two spheres is only that common point of contact. So I can say in this case S1 intersection S2 is simply one point. Okay, so let me explain by again the figure. So I am taking one sphere like this and say another sphere, say take this is blue. Okay, so another sphere is like this. Okay, and suppose the centers of this, as this is S1 and this is S2, the center is C1, for S2 the center is C2, and the distance between this is exactly equal to R1 plus R2. So I should not draw like this. Let me remove this and put this sphere. Yes, so this is the situation between the two spheres. In this case, they are touching each other from outside externally. Remember, both are set of points or the surfaces. So this is C2, and the distance between them, this distance C1, C2 is equal to R1 plus R2. So this is R1 and this is R2. So from this to this distance is R1 and this distance is R2. So C1, C2 is exactly equal to R1 plus R2. In this case, there is only one point in common between the two spheres, and it is this point, the point P. Okay, so here in this case, S1 intersection S2 is equal to singleton P, and the two spheres are touching each other externally or tangent to each other at one point. Now let us go to the third case. So in this case, if this is not the thing, means if neither C1, C2 is greater than R1 plus R2 nor C1, C2 is equal to R1 plus R2, then we go to the case C. So I am writing this way. Suppose in this case, suppose the distance C1, C2 between the two centers is strictly less than R1 plus R2. Okay. In this case, we again further classify this into different categories, and I will call it as subcase number 1. In this case, in addition to the condition C1, C2 less than R1 plus R2, you must also check if C1, C2 is say strictly greater than mod of R1 minus R2. Remember, I am taking modulus because the two radii may be different, so we don't know what is which number is bigger or smaller. So we take the absolute difference between the radii, and if this distance is greater than R1 minus R2, in addition to this, then the two spheres S1 and S2 intersect each other in a circle. So the intersection is a circle, or it is also called circle of intersection of the two spheres. That is, in this case, I can say S1 intersection S2 is equal to a circle. Okay, let us understand this by diagram. What is the situation in this case? So we have one sphere. Okay, sorry. And another sphere is like this. Let me take, okay. Yes. So let me take a second sphere, which is intersecting this first sphere like this. And yes, so this is the situation in this case. And let me write down, this is the first sphere S1, this is S2. The center of the first sphere is somewhere here, say it is C1. Center of the second sphere is somewhere here, C2. And if you find the distance between this two spheres, the distance between these two spheres, okay, C1, C2 is less than R1 plus R2. So I can say, if this is the common point here, I can join this by a line segment. Sorry. And that is the radius of the first sphere. If I join this point with C1, then yes. So this is my radius R1, and if I join this with this, it is the radius R2. So R1 plus R2 is greater than C1, C2, the triangle rule. Okay, so this is the situation, and the intersection set of the two spheres is something like this. It intersects in a circle. So that circle I can draw like this. So this is the circle of intersection. Yes. So this way the two spheres will intersect. And sometimes we are interested in finding the center and radius of this circle of intersection. So that we will see in the problems which we discuss later on. So this is the subcase number 1 of C. C1, C2 is greater than R1 minus R2. So whenever C1, C2 is less than R1 plus R2, you find the absolute difference and compare the distance C1, C2 with R1 minus R2. If C1, C2 is greater than R1 minus R2 and less than R1 plus R2, you can say the two spheres intersect in a circle. So this is the circle of intersection. I can this is the circle of intersection. Okay, so it is given by this. Now let us go to the next subcase. So number 2, if C1, C2 is less than R1 plus R2 and if C1, C2 is exactly equal to mod of R1 minus R2, then in this case, then the two spheres are touching each other. Two spheres are touching each other internally. Okay, that is a tangent from inside. In this case, the one sphere will be contained in another sphere and they are touching each other. Okay, so again intersection in this case is also a single point. So S1 intersection S2 is again some one point. Let us understand this situation by diagram. So let me take again two spheres, say one sphere okay, this is my one sphere. Let I put it in the center and I am taking another sphere, say like this, and this sphere is touching this this sphere at some point. Say let me keep it here, and now you can see if the centers of these spheres, this is C1, this is C2, okay, this is S2, this is S1, the two spheres, and this radius is R1 and this radius is R2, but let me first join these two, C1, C2, and this much is the radius of the smaller sphere, that is R2. So in this case there is only one point in common. This is the only point of intersection. Okay, so S1 intersection S2 is singleton P, but they are touching internally. One sphere is contained in another sphere. Okay, remember the two spheres, a sphere is always a surface. So one surface is inside the another surface. Sphere is not a solid object. It is a hollow surface. Okay, and we are considering points on the surface as a set S1 and S2. Okay, and discussing the intersection. So in this case, S1 intersection S2 is only this point. Okay, and there is a common point of say intersection. We can draw a tangent plane at this point. You can draw a plane which is touching to both the spheres, and we can write down the equation of that tangent plane just by taking the difference of the two equations, that is S1 minus S2 equal to 0, which I will be discussing later on when we solve the problems. Okay, the last case, again let us recall. In the case C, when C1, C2 is less than R1 plus R2, we have to consider three more subcases. If C1, C2 is greater than R1 minus R2, then intersection is a circle. So this is the circle of intersection. If C1, C2 is equal to mod of R1 minus R2, then the two spheres are touching each other internally. Okay, so they are tangent to each other internally. And now the last case about their intersection, or the last possible situation, is the subcase number 3. And it says, if in addition to C1, C2 less than R1 plus R2, if C1, C2 is strictly less than mod of R1 minus R2, then the two spheres, in this case also, two spheres do not intersect. Remember, do not intersect each other. Okay, and the two spheres are different, we know, but in this case one sphere will be contained in another sphere. So the sphere with the small radius is contained in the sphere with the larger radius. So I can say, and the sphere, any sphere, either S1 or S2, is not fixed. The sphere with the smaller radius is contained in the sphere with the larger radius. Okay, so in this case also the intersection is empty. Here also, in this case, S1 intersection S2 is 5. So let us understand this situation by, again, simple figure. So I am taking one sphere like this. Okay, and another sphere. Is say somewhere here. Okay, and suppose the centers are like this. This is center C1 of the sphere S1, and this is the center C2 of this sphere S2. Okay, and this distance C1, C2 is less than R1 minus R2. So this is R1, radius of the first sphere, and this is R2, radius of the second sphere. Okay, so the two spheres are not intersecting at all. So S1 intersection S2 is empty set, and here you can see that S2 is contained in S1, because in this figure I have taken radius of the sphere S2 as smaller radius. So S2 is a sphere with a small radius which is contained in the sphere S1 with the larger radius. Okay, so these are the different situations about intersection of two spheres. Okay, let us solve some problems based on this.